In this video, I'm going to cover section 10.4, Polygons, Perimeter, and Circumference from Contemporary Mathematics by OpenStax. The learning objectives for this section are the following. Identify polygons by their sides, identify polygons by their characteristics, calculate the perimeter of a polygon, calculate the sum of the measures of a polygon's interior angles, calculate the sum of the measure of a polygon's exterior angles, calculate their circumference of a circle, and solve application problems involving perimeter and circumference. So let's begin by talking about what is a polygon. So polygon is an amalgamation of the Latin prefix poly, which means many, and gon, shape. So many-sided shape. So it's a closed two-dimensional shape classified by the number of straight line sides. So if all the sides of a polygon have equal length, then they are called, or that particular shape is called a regular polygon. So all the sides are equal, that is called a regular polygon. So what makes a polygon concave is having an interior angle that measures greater than 180 degrees. And so it kind of looks like they're hollowed out or cave in, so to speak. And then convex refers to the opposite effect, where the shape is rounded out or pushed outward. So kind of think about if you had a something that looked like that. Here, this angle, the interior angle here, is greater than 180 degrees. That would be a concave. And then that same figure where it wasn't caved in, kind of like that, instead if it went upwards and that upper angle was less than 180 degrees, then we would have this five-sided figure, which, as you can see over here, is called a pentagon. So this pentagon would be concave versus convex. So that's kind of the difference between those two terms. So we do have special names for all the polygons based on the number of sides. I'm just gonna, these aren't all of them. These are just the just a few. So we have a triangle, of course, that's three-sided. Quadrilateral, quad coming from the term for square. So it has four sides, and so it's square. And then pentagon for five sides, hexagon, heptagon, and octagon, ending with 8. And so each of these prefixes, tri, quad, penta, hexa, hepta, octa, that all really goes back to its Latin root, talking about Latin as far as the numbers. So tri is 3, quad is 4, penta 5, so forth and so on. So a special subgroup that we talked about, the four-sided polynomials, is the quadrilaterals. So they make up their own little subgroup in geometry of four sides. So let's talk about the difference between the different quadrilaterals. The first is a trapezoid. So a trapezoid has these two sides that are the same, and then these two sides that are not the same. And, they're also the same. But we've got these two parallel sides and then these two slanted sides. And the two parallel sides, of course, never intersect. And then these two slanted sides give us that trapezoidal shape. If I kind of drew it and made it more elaborated. So these are the same. Yeah, I need a third tick down here, or hash mark. So you kind of get that idea that there's four sides, two sides are parallel, and then two sides are slanted and the same. So a parallelogram is one where all the sides are kind of co-parallel to each other. In other words, that if you're across from a side, that side across from you is parallel, and it's never going to touch. Now, in this case, the opposite sides just have to be parallel and equal in length. That does not mean that they have to be, so like these are the same length and parallel to each other. These are not the same length as the other two. So it could be kind of, squashed, or it could be kind of short, and you can have a long parallelogram, kind of like that. So parallelograms can come in different shapes. The important part is that there are no right angles and the sides are parallel to each other. So that's kind of the important part about being a parallelogram. Now in a rectangle, it is a parallelogram. So rectangles are parallelograms because the sides are parallel to each other. They'll never intersect, but all of the angles inside of a rectangle are 90-degree angles, which tells us that if we do 4 times 90 degrees, that's 360 degrees. So a rectangle has to have 360 degrees. In fact, actually, so does a parallelogram. It has to have 360 degrees. And so does a trapezoid. In fact, all 4-sided figures in our normal geometry have to have 360 degrees. Rectangles are special in that they're all 90 degrees in this case. So that's special to them. And then a special type of rectangle is a square. And so a square is a rectangle whose all sides are equal. And so you kind of, starting with parallelogram here, you kind of build. So all rectangles are parallelograms and all squares are rectangles, but you can't go backwards. There are rectangles that aren't square, of course, and there are parallelograms that are not rectangles. Anyway, so the last quadrilateral we have here is called a rhombus, and a rhombus is a parallelogram with all equal sides, but we don't have to have right angles, and so you kind of get this diamond-shaped figure. So all the sides are the same, and then opposite sides are parallel to each other. Okay, let me draw it on this other picture. Like these sides are parallel to each other, but you do not have to have right angles. They have to add the 360 because that's a feature of a quadrilateral, but they don't have to be the same. So one thing we always want to find that's really kind of applicative in geometry is the idea of perimeter. So perimeter is the measurement on the outside of a region, and so these are really good because if you have land and you want to put a fence, then you need to know how much perimeter the fence is going to have and things like that. So for quadrilaterals, for 4-sided figures, right, it's kind of nice. Let me back up here. I guess it's not just, I guess I should back up and say not necessarily quadrilaterals, but parallelograms are nice because, again, these are parallel to each other. These opposite sides are equal. And so if we call this the length, so these two sides are the lengths and these two sides are the widths, then the perimeter is just adding up the distance around. So that's going to be L plus W plus W, which is 2L plus 2W. And so that's where we get the perimeter formula, is 2L plus 2W. And that is kind of special for parallelograms or anything that is born out of a parallelogram, such as a square or a rectangle. Now, if you're a square, then, if you're square, then your perimeter is just 4 times the side length, which you can call L, or 4 times W, and that's because L is equal to W in a square. So it doesn't matter for a square, it's just 4 times the number of sides, they're all the same. So let's look at this example. Here is a non-quadrilateral. This is a pentagon, so it's 5 sides. Specifically, it is a regular pentagon, which is important. That tells me that it has equal sides. Okay, so that means that all of these sides are 7 centimeters in length. So the perimeter is going to be 7 times 5, which is 35 centimeters. So nice and easy in that regard because it was a regular pentagon. So some interesting formulas here that we have is sometimes we want to know like what's the sum of the interior angles of a polygon. So in other words, let me start with a rectangle. So here we have a rectangle. We've already talked about that, in a rectangle, they're all 90 degrees. So 4 times 90 is 360. So let's see if we can come up with, where does this formula kind of, derive from? So we've got our rectangle, okay? And then that's the one we currently have. But what if we went backwards? So let's go backwards for a minute. Let's go to a triangle, okay? So let me get my shape creator here. So we'll go to a triangle. And then a rectangle. And then a pentagon. And we will go as far as, let me see if I can draw a hexagon. 3, 4, 5, 6. So we know in a triangle we have 180 degrees. We talked about that last time. And then in a rectangle, what we could do is we could slice the rectangle in 2, cutting it down the middle. This is called the diagonal. And so we have 2 triangles, right? So we have 2 triangles. And so that would be 180 degrees times 2, which is 360 degrees. We could do that same thing here with the pentagon. If we cut it into along the diagonals there, then we create 1, 2, 3 triangles. And so that's going to be 180 degrees times 3, right? So 180 degrees times 3 is 540 degrees. And then one more time, just so we see the pattern. 2, 3, 4, 5. I created 2 5-sided figures. All right, so I've redrawn that so that we could create 1, 2, 3. So that creates 1, 2, 3, 4 triangles. So 180 degrees times 4 gives me 720 degrees. And so each time we add a side, starting with a triangle, which has 3 sides, we end up adding an interior triangle. And so what we see here is this pattern of the number of sides is 3. So the number of sides is 3. And this would be 1 times. And we have that number of sides minus 2, number of sides minus 2 times 180 degrees, and that's going to equal the total angles. Because each time you create a diagonal inside one of these polygons, you're going to create a triangle inside, which should have 180 degrees in it. And so, for example, here we had 6 sides, and we did 4, which is 2 less than 6. Over here, the pentagon had 5 sides, and that's and we did 3 times, so that's 2 less. So that's where we get this formula, is the number of sides minus 2 times 180. We always have 2 less triangles inside. So if you remember this setup, like, and you say, oh, well, it's an octagon. You could draw an octagon and divide it along the diagonals, and you should get 6 triangles. So you could just do 6 times 180 to get your number of angles. Now, going backwards, the measure of each interior angle within sides is given by, within sides is given by n minus 2 times 180 divided by n. So what this means is, like, for example, let's go back. Let's go to a triangle. So for n equals 3, if they're all the same, if all the sides are the same, this is an equilateral triangle. So what we're saying is the measure of all of these little angles inside is going to be A equals, there's 3 sides, minus 2 times 180 degrees, all over in 3 sides. Well, we kind of already know this, right? Because that's 1 times 180, so that's 180 degrees divided by 3, so that's 60 degrees. So an equilateral triangle has 60 degrees. Well, what about quadratic or quadrilateral, right? 4 sides. Then if n equals 4, then that's going to be 4 minus 2 times 180 degrees divided by 4. But we know that a quadrilateral has 360 degrees divided by 4, and that's going to give you 90 degrees. And so all that's doing is telling us each of these have to be 90 degrees. If you had a pentagon, and it has to be a regular pentagon, I'm not drawing it well here, so that would be the angles. So each of these angles in a regular pentagon would be 5 minus 2 times 180 degrees divided by 5. And then we would do that, so forth and so on. And that would tell us what each of those angles are inside. So here's an example of using this to do find the angles for a regular octagon. So let's see if I have an octagon picture here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Let's see if it tries to make it a circle. All right, so here's that octagon from the textbook. And so what we're trying to find is, first, what's the total angles? And second, what do each of these angles equal? All right, so the total angles is going to be 8 minus 2, so 8 minus 2 times 180 degrees. I can write that better. So 8 minus 2 times 180 degrees. So that's going to be a total of 1,080 degrees. And then to find the interior angle measure, we can do A equals, we could technically do that whole formula again, but a shortcut is, well, we've already found the total number of angles, which is 1,080, and then just divide it by 8. So if I divide that by 8, that gives me 135 degrees. So each one of these angles inside of a regular octagon is 135 degrees. So another interesting thing that you might need to find, if you use geometry in your job as you're a contractor or, something like that, is what about exterior angles of regular polygons? And so an exterior angle is when you take an angle or a side and you extend it out. So this would be an exterior angle, and that would be the interior angle. Now, for a regular polygon, for example, here in this equilateral triangle, we know that all of these are 60 degrees, and those two angles are supplementary to each other, right? They're supplementary to each other. And so if we did 180 minus 60, that would give us 120 degrees. But according to mathematicians, they have found this formula, or discovered this formula, that says that the exterior angles of a regular polygon with n sides would be 360 divided by n. And so if we do b equals 360 divided by 3, so 360 divided by 3, that should give us 120, and it in fact does. And so if we did, for example, so this was an example of an equilateral triangle, a regular quadrilateral is really just a square, right? And so we know this is 90 degrees, and so this also has to be 90 degrees, because 90 plus 90 is 180. And so that tells us that if we would have just done 360 divided by 4, we know that's 90 degrees. So that's how you can find exterior angles quickly. It's just 360 divided by n. So let's look at, here's a good example. This is a 1, 2, 3, 4, 5. So this is a regular pentagon. Penta for 5. So regular pentagon. What are all these angle measures, these exterior angle measures? Well, that's just going to be as simple as doing b equals 360 divided by 5. So if I do 360 divided by 5, then I get that's equal to 72 degrees. You know, if you're thinking, how is that possible? Like, is that true? Well, go back to what we were doing. We know that a pentagon is basically smashing together 1, 2, 3 triangles. So 3 times 180 degrees is 40, 540 degrees. And then if we do 540 divided by 5, because there's 5 sides, so 540 divided by 5, that's 108 degrees. And so each one of these interiors angles, let me erase some of this so I can see. So like this angle here is 108 degrees, and then it is supplementary, meaning that it would be taken away from 180. So 180 minus 108 is 72 degrees. So this is like a quick trick to get there, but it's the same thing as figuring out what the interior angles are, and then just figuring out that it's a supplementary angle to it. So a special type of, figure here is a circle. It kind of is it's not necessarily a polygon. Polygon means multi-sided or many sides, and this, a circle is perfectly round, but it still has perimeter. But because it is a special figure, and it's been studied by itself for, eons and eras within our the human growth and generations, that it gets its own name. The perimeter of a circle is called the circumference. We don't say the perimeter of a circle, we say the circumference. So to find the circumference, we use the formula C equals pi times d, which is really circumference equals pi times diameter. And pi is a number that it's a kind of a never-ending decimal, but usually we just say it's 3.14, 159 ... That's as many nut digits as I remember, 3.14159. And then the diameter, so D is the diameter. That's the full length across the circle. That's the diameter. And then the radius goes from the center out to the edge of the circle. The radius is half of the diameter. So you could either write it as C equals pi times D, or you could say C equals 2 pi times the radius, or pi times 2 times the radius. So that's kind of the formulas for circumference. They give you the same thing. It just depends on what you have, which one you should use. So for example, say we wanted to find the circumference of a circle with a diameter of 10 centimeters. So here we'll draw a circle. It has a diameter of 10 centimeters. So going across the entire length of it would be 10 centimeters. So if we wanted to find the circumference is going to be pi times D. So that's just going to be 10 pi, which is going to be 31.4 centimeters. If we round it to the nearest tenth of a centimeter, it's just going to be 31.4. So what about more of a real world kind of carpentry type example? So here we have a window, and we want to make a trim for the window. The trim's going to go on the outside of the window. And so this window is made up of this rectangular portion here, and then it has this, we call this a semicircle. Half of a circle is a semicircle. So this semicircular piece here. So I don't think I can draw that very well. So a semicircle, yeah. And then this rectangular piece. So when it comes to the trim, we don't care really about this inside piece, right? Like this in here, we don't care about. We just care about the perimeter. So let's start by finding the perimeter of the lower rectangular piece. Well, that's going to be, because it is a rectangle, this other side is also going to be 12 feet. You don't want a mismeasured rectangle. So 12 feet on that side. So that's going to be 12 feet plus 12 feet plus 6 feet. So that's going to be 24 plus 6 feet. So that's going to be 30 feet. And then to find the perimeter of the top, we need to find the circumference if there was a full circle, but we're going to cut it in half. So it's going to be, if we found the full circumference, notice this is a diameter of 6. So it would be pi times 6. So if I did that, if I did 3.14159 times 6, that's going to give me 18.8 feet, because we're still in feet, okay? But we're going to cut that in half, and so we're going to do half of the circumference, and that's going to be 9.4. So if I divide it by 2, that's going to give me 9.4 feet. And so the total perimeter is going to be 39.4 feet for the trimming on this window. All right, and so that's the end of this video for section 10.4, polygons, perimeters, and circumference. If you haven't already, I highly advise you go over and read the textbook, freely available online, openstacks.com, or linked inside of the learning management system. Throughout the section, while you're reading, I highly advise you take some handwritten notes and try the your turn problems. Those are very helpful, and the answer to those are at the end of the section. And then once you've watched this video, taken the notes, read the chapter, head on over to the LMS and work on those online assignments for this particular section.